Okay. Well, so we've gone through some of the initial floating point instructions: load, store, initialize, exchange, add, subtract, multiply, and divide. We also have a whole bunch of miscellaneous instructions. By the way, guys, we're just, again, hitting the top of the iceberg on these. There are a lot more. I'm just introducing you to some that you will see quite often. So let me tell you what these guys do real quick. Float absolute value. As you would suspect, the stack top is replaced with the absolute value of the stack top. Float change sign, stack top, is going to be replaced with the negated stack top. Float round to an integer. This rounds st to an integer value. And then f square root replaces st by its square root. Okay, as I mentioned, these are just a few. There are also trigonometric, exponential, and logarithmic functions, as well as many other functions. Let me quickly show you. So we've looked at some of these. We need to also get to a point where we can make some decisions. So I have some floating point comparison instructions. Each of these instructions compares stack top with some other operand, sets the condition code bits 14, 10, and 8 in the status word register. Now, these bits are named, let's see, I'll show you, we'll do this in a table, where I'm going to have the result of the comparison and what happens in each one of these bits. Bit 14 is referred to, it's named C3. Bit 10 is C2, and bit 8 is C0. Okay, so the result of the comparison. If I do compare and the stack top is greater than the other operand, then all three of these condition code bits will be cleared. If stack top is less than the other operand, then C0 will be set. Everything else will be cleared. If stack top equals the other operand, C3 will be set. Everything else will be cleared. And whoops, that's not a really good zero. What if the two values are not comparable? Then all of these values, all these condition code bits will be set. So remember this, because we'll come back to this. And notice this spacing, because we'll also come back to this. Okay, so that's how the comparison works. Here are the comparison instructions. So fcom compares stack top, compare stack top, and st1. Okay, this is going to compare, this next one is the stack top and st number. This one is going to compare stack top and the floating point value stored in memory, and this will compare stack top and the integer value stored in memory location to be indicated by you. Each one of these, again, will do a subtraction, that's what a comparison is, and then set those bits according to the diagram that we just drew. Okay? Alright, some more comparison instructions. What if I want to test for 0? This one is going to compare stack top and 0. Okay? fcom p is going to compare stack top 1, and then pop stack top. And then this is going to compare, let's write this one out, stack top 1, and then pops a stack twice. So in effect, it compares the two ST1, and then pops both of those off. All right. So when we do those comparisons, what do we do? Well, let me show you a few more. Then we'll talk about what do we do with the results of those. In this one is going to compare stack top and stack top number, and then pop stack top. Okay. Again, we're looking at the P suffix on these. This one's going to compare stack top and float val and pop stack top. And finally, this one's going to do an integer comparison of stack top and int val, whatever the integer value in memory is that you indicate, and then pop stack top as a result. Okay, now that we've done this, let's go back to something I told you at the beginning of this discussion. We talked about status word access. Remember, we went through the fact that the floating point processor has 8 80-bit registers that are organized as a stack, but then we also said there are several 16-bit registers, including the status word register. So the conditional jump instructions that we looked at, well, no, the comparison instruction we just looked at will, according to the results of the comparison, sets C3, C2, and C0, the condition code bits. Conditional jump instructions look at the bits in the flags register, not in the status word. So that's the problem. The conditional jump instructions that we've learned look at flags, not the status word. So how do we get flags into status word? Well, I just so happen. Remember I told you we were going to have an exception to the fact that there really is no data transfer between the floating point unit registers and the general registers in the CPU. This is the exception, okay? So in this case, this instruction provides access to the status word bits. In the first case, this is going to copy the status word to some memory word that you indicate. In this second case, this one's going to copy the status word to AX. Okay? There are also some similar instructions available for the control word, but we'll not talk about that. I just want to tell you, this is one of the few exceptions, but not the only one. So this one in particular looks fairly promising. The only problem is that's still not E flags. It's AX. So what am I going to do? Well, let me show you some code. Okay, we'll go through this a line at a time. Let's say I execute fcom. This is going to do a comparison. Is stack top greater than stack top 1? That will set or clear C3, C2, and C0. Okay? Then status word is going to store the status word in AX, copy the condition code bits to AX. Ooh, here we go. I have an instruction. This is going to shift the condition bits to E flags. So in particular, this instruction is going to copy AH into low order 8 bits of E flags. Okay? Now, what that's going to do is C3 will be in the 0 flag position, or bit 6, and C0 will be in the carry flag position, or bit 0. Okay? This is going to make it possible for us to use conditional jump instructions, unsigned. Okay? So, I'll be able to use unsigned conditional jumps and skip, in other words, based on this. And you say, oh my gosh, that seems like an awful lot of work. It is. And in 64-bit mode, which we're not going to go over right now, this instruction is not even available. But I have 2 additional comparison instructions that will directly set the flags in the flags register. You know what? I don't think I have it. No, I don't. And we're not even going to go over this stuff. So let me just go back here. Whoops. And say, now that I've already made some notes and erased those previous notes, let me show you those 2 instructions in 64-bit mode. So let's change this. Gosh. Change that back to 64-bit mode. And in 64-bit mode, again, don't have access to Shift AH to E flags, but I do have FCOM-I, ST, ST number, and I also have FCOM-I and POP, ST number. Okay, both of these will automatically transfer those values into E flags, bits 6 and 0, 0 flag and carry flag. Alright guys, that's it for the floating point instructions we're going to cover this semester. Let's see how far we get in class. I'm going to show you several examples, and hopefully we'll be able to get to recursion as well.